Energy is a measurement of the ability of something to do work. It is not a material substance. Energy can be stored and measured in many forms. Although we often hear people talking about energy consumption, energy is never really destroyed. It is just transferred from one form to another, doing work in the process. Some forms of energy are less useful to us than the others. For example, low-level heat energy. It is better to talk about the consumption or extraction of energy resources. For example, the coal, oil, or wind than consumption of energy itself. A speeding bullet, for example, has a measurable amount of energy associated with it. This is known as kinetic energy. The bullet gained this energy because work was done on it by a charge of gunpowder, which lost some chemical potential energy in the process. Another is a cup of coffee has a measured amount of thermal energy, which is it required via work done by a microwave oven, which in turn took electrical energy from the electrical grid. So in practice, whenever work is done to move energy from one form to another, there is always some loss to other forms of energy such as heat and sound. So for example, a light bulb is only about 3% efficient at converting electrical energy to visible light, while a human being is about 25% efficient at converting chemical energy. So how do we measure energy? The standard unit used to measure energy and work done in physics is the joule, which has the symbol J. In mechanics, 1 joule is the energy transferred when a force of 1 newton is applied to an object and moves it to a distance of 1 meter. But we have this another common unit of energy, which is the calorie. The calorie is the amount of energy in an item of food. If often is often written in calories, you can see that one at the back of the food. So a typical 60-gram chocolate bar, for example, contains about 280 calories of energy. 1 calorie is the amount of energy required to raise 1 kilogram of water by 1 degrees Celsius. As you have observed, the concepts of work and energy are closely tied to the concept of force because an applied force can do work on an object and cause a change in energy. Going back to the definition of energy, energy is defined as the ability to do work. So work is actually a concept of physics, okay? It's much more narrowly defined than commonly use of the word because we are utilizing this word most of the time, the work done, okay? The work that we have performed. But in physics, work is done, okay, on an object when an applied force moves it through a distance. In our everyday language, like work is related to expenditure of muscle effort, but this is not the case in the language of physics. A person that holds a heavy object does not do physical work because the force is not moving the object through a certain distance. So work according to the physics definition is being accomplished while the heavy object is being lifted but not while the object is stationary. So when we talk about work in physics, work, okay, is equal to force times distance. So where F is the applied force and multiply that one with the distance moved. So if you exert a force on an object and the object is not moving, even a lot of force is exerted into it, then work is work is not work is zero. Okay, so work is not done. That is in accordance with the definition of physics. So the SI unit of work is joule, which is equivalent to Newton meter or kilogram meters per second squared.